Alright, so now we are back in the lecture portion of the course. So if you still have the tutorial project open, go ahead and close that now so you don't accidentally make any unwanted changes. Okay, so for this lecture, I'm going to introduce you to the concept of blueprints. So blueprints are really cool because they basically blow the door wide open as to what you can accomplish with the engine. They are designed to be extremely flexible and give you near unlimited creativity when it comes to adding features to your game. So far, we have been learning how to construct environments that can be used for games, but the environment is only one half of a game. The other half is the logic that determines how the environment can be interacted with and how the game is actually played. So this is where blueprints come into play. In Unreal Engine, a blueprint is an asset that contains data and instructions. Using blueprints, we can keep track of health, energy, score, and anything else we need to keep track of. And we can specify game logic, like what are the requirements for completing a puzzle? What happens when that puzzle is complete? What happens when I shoot an enemy? What happens if a 2-ton piano falls on me? And so on. So there are two main types of blueprints, the level blueprint and blueprint classes. A level blueprint is used to hold data and instructions for a particular level. So it might hold data such as the time remaining to complete the level, or the number of keys you've collected in that level, and so on. It would also be used to store instructions that pertain only to that level. For example, let's say there was a spot in a level where there was a bridge, and when the player crosses that bridge, a meteor will fly across the sky. If that's a one-time unique occurrence just for that spot in that level, it would make sense to store those instructions in the level blueprint for that level. Blueprint classes are a way to turn any actor or asset into a blueprint. This allows us to create objects with custom traits and behaviors. So let's say that I was building a haunted house, and let's say I wanted to have a chair that floated up and down as if it were possessed or something. Let's also say that I wanted my character to be able to shoot the chair, and if I hit the chair enough with my projectiles, it will destroy the chair. I can achieve all of this by creating a blueprint class out of this chair mesh. So within the blueprint, I could specify that the chair should move straight up and down over and over again, starting from wherever it is placed in the level. I could also specify that the chair should contain a variable called health with a default value of 100. I could also say that anytime the chair was hit by a projectile, that 10 should be subtracted from its health. And finally, I could specify that if the health of the chair ever gets to 0 or below, that the chair should be destroyed. So one of the great things about blueprint classes is you can use them to create as many copies or instances of your creation as you want. Think of this like a blueprint for a house. With one blueprint, you can make several instances of the same type of house. So using my haunted chair as an example, once I completed the blueprint, it would be available to me in the content browser. And then each time I dragged it into the viewport, it would create a new instance of the chair. Each chair would float up and down, starting from the position they were placed, and each chair would have their own copy of the health variable. So if I damaged one of the chairs, its health would be 90, while the other chairs would still have a health of 100. So this is an important concept. Every instance of a blueprint class gets its own copy of the variables specified in the blueprint. Okay, so that's the general concept of blueprints. Now let's take a look at blueprints in action. The first thing I'm going to do is edit the level blueprint for this level so that 2 seconds after the level begins, the game will exit. So not a very practical thing to do in the real world, but it will provide a nice simple example for your introduction to blueprints. So to open the level blueprint, I just need to go up to the toolbar, expand the Blueprints menu, and then click on Open Level Blueprint. This will open the Level Blueprint Editor. And inside the Level Blueprint Editor, we have the Event Graph. The Event Graph is the area of a blueprint where you script the logic. If you're a programmer, the logic can be scripted in pure code using C++. However, Epic Games has developed a visual scripting system that allows non-programmers to script logic, and is actually pretty convenient even for experienced programmers. So this scripting system works by using various nodes that each serve a specific purpose and then connecting those nodes together. So by default, the level blueprint starts off with 2 nodes in the graph. These are common nodes to start off with, so that's why they're here by default. They are disabled to start with, which is why they are transparent, but they can be used right away by connecting them to another node. The first node is the Event Begin Play node. An event node is a node that is activated when a certain event occurs. So an Event Begin Play node inside of a level blueprint will be activated by the event of the level first starting. The top strip of an event node will be the color red, and it will have this icon here of an arrow inside of a diamond symbol. So you can see the second node here is also an event node. The event tick node is a node that is activated on every tick of gameplay. Before every frame of the game is drawn on the screen, any logic connected to the event tick node will be executed. This is useful, for example, in a situation where you need to constantly check certain conditions that, when met, will have an immediate effect on the game. Alright, but in this first example, I'm going to use the Event Begin Play node to cause the game to exit after a couple of seconds. So, as I said before, the Event Begin Play node will be executed when the level first begins. As a consequence, any nodes connected to the Event Begin Play node will get executed as well. So I could just create the node that will cause the game to exit and connect the Event Begin Play node directly to that, but I'm going to add a little bit of a delay so you can at least see that something is happening. So to cause a delay in the execution of my logic, I need to use a delay node. One way to create a new node is to right-click in an empty space in the graph and then select the node from the menu. There are many nodes available to choose from, and they are organized into categories. But if you know the name of the node you're looking for, you can use this search box up here. So I'm going to type delay into the search box and choose the delay node. The delay node is a function node. Function nodes are light blue and have an icon of a lowercase f. In blueprints, a function is a node that performs a specific task. So the task of the delay function is to wait for a specified amount of seconds before passing execution on to the next node. So these icons here on the nodes are called pins. Pins on the left side of a node are input pins, and pins on the right side of a node are output pins. Pins with this white icon here that looks like a play button are execution pins. So execution pins on the left side of a node represent the beginning of the execution of that node, and execution pins on the right side of a node represent the end of the execution of that node. So if I click on this pin here and drag off of it, it will create a wire that I can connect to another pin. Because the pin I'm dragging from is an end of execution pin, I will only be able to connect this wire to a start of execution pin. So I will connect this wire to the start of the execution pin on my delay node. So what this is saying is, once the Event Begin Play node finishes execution, begin execution of the delay node. And then if I connected a wire from this pin to another node, it would activate that node once the delay node finished execution. Okay, so again, the purpose of a delay node is to delay for a specified number of seconds. You can specify the duration directly here, or you could connect another node containing a number into this input pin, and it would use that number as the duration. But right now, I'm just going to specify the duration directly and enter 2 so that it will delay for 2 seconds. Also, another thing you should be aware of regarding the delay node is that it doesn't cause the game to pause. In other words, it doesn't delay the execution of all logic in the game, just within the flow of wires it's connected to. Okay, so now I just need to connect this to a node that will exit the game. When I created the delay node, I created it first and then connected these two nodes together. Another method is to drag a wire off of an end of execution pin and then release the mouse, and that will cause the node menu to appear as well. And then when you choose your node, it will automatically connect the two. So I'm going to drag a wire off the end of the delay node, and then in the search bar I'm going to type quit, and then select the quit game function. So when this node is activated, it will cause the game to exit. And the quit game node has a few input pins, giving you some different options when quitting the game. If this were a multiplayer game and I got a reference to one of the players in the game and then connected that node to this pin, it would cause only that specific player to exit the game. There's also this quit preference variable where you can select between quit to have the application actually close and background to make the application not actually close but just run in the background instead. And then ignore platform restrictions gives you the option to override any restrictions related to quitting games that might exist on the platform the game is running on. But I'm just going to leave this the way it is. And now that I have finished scripting my logic, I will need to compile the blueprint. Compiling just means that the engine will convert the logic I created into machine code that the computer can understand. In order to compile the blueprint, you can use the Compile button in the toolbar. You'll notice the button currently has this yellow icon. This indicates that there are changes to the blueprint that haven't been compiled. So I'm going to click on the button, and now the icon changes to green, indicating that this blueprint has successfully compiled. So now I'm going to click this Save button to save my work. And level blueprints aren't saved on their own, they are saved along with the level itself, so this button will actually save the entire level. So now I'm going to close the level blueprint editor, and now when I press play, you will see the game run for 2 seconds and then exit. Okay, so the final thing I'm going to cover in this lecture are comments. Comments are a way for you to write notes in your blueprints. So when you come back to them later, you can quickly understand their purpose. So for example, I can select these nodes here, right click, and then at the very bottom I can select Create Comment from Selection, or simply press the C key. And then it will group these nodes together in a box and allow me to write a comment explaining what the nodes do. So I'm just going to write delay for 2 seconds, then exit game. So now, whenever I come back to this blueprint in the future, I can quickly read in plain English what this grouping of nodes is meant to do. And because these nodes are grouped together in this box, if I move the box, all the nodes inside it will move with it. So comments also help to organize your nodes and to quickly move around sets of related nodes. Okay, so that will do it for the lecture on the introduction to blueprints.